So this is the one talk I think this week that I'm giving not as executive director of OSG, but as PI of a new funded NSF award called the NRP, and as co-PI of the Pacific Research Platform. And you'll see what these things are in a moment. And the purpose of this talk is to elucidate the relationship between OSG and the XRPs, from PRP to NRP to GRP, where P stands for Pacific, N for National, and G Global. And I'll explain what this is all about as I go through. So first, let me start. And I hope that you don't hear the sledgehammer behind me, because I hear it and it's driving me crazy. But I hope that that is not, you can't hear this through my, my audio. So shared vision and aspiration. We have a shared vision between OSG and the NRP, and it's the obvious democratization of access. We've seen this slide now many times, and the desire to create an open national cyber infrastructure that allows the federation of CI at all 40,000 accredited degree granting higher education institution, non-profit research institution, and national laboratories. Basically kind of stuff that I talked already on Monday about, and that came up again in the session on Tuesday in the Missing Million session. And so we're in for openness for an open society, and that basic philosophy and thrust and desire and goal is 100% shared between PRP, NRP, and OSG. And now what's different? And I want to think of what I encourage you to think about. The difference is really where you federate. And you can, and I'm going to give you 3 examples. And I'm not implying that these are the only examples necessarily. It's just the examples that are sort of canonical in a way. And in a way, you can think of this as going up the stack as you go down the slide. So you can and federate at the container orchestration layer, for example, Kubernetes, and that is implemented by the Pacific Research Platform, and I'll talk more about this in a second. You can then federate independent container orchestration frameworks, meaning one side has Kubernetes, the other side is Kubernetes, and you want to federate the 2 independent Kubernetes clusters with each other. And you can do this either via Slate or natively via Admiralty on Kubernetes. Or you can go even one layer up and say, I'm going to federate storage and compute clusters at the storage and batch system layer. And that is sort of the traditional OSG setup with the compute element. Now, in OSG these days, as you've seen in some of the presentations, we have gone beyond the traditional setup. And so now there's other ways in OSG to do this as well. So there is some gray between these different ways of doing things. But my point is that the key thing here is that the more control you want, the more effort it is to join and operate the federation. Meaning, if you're at a higher layer, say at the batch system layer, you need effort to run a batch system, you need effort to support accounts, the storage system requires effort. There's an entire plethora of effort that is required to work at a higher layer. If instead, and therefore at that higher level, you have lots of control. You have all the control in the world, in a way, the usual things of OSG. Now, if you, on the other hand, work at the very lowest layers, and as you see on the next slide, you can go all the way down to IPMI. So you have no control, because you're giving everything away. You're giving even the OS responsibility, the maintenance of the operating system responsibility, away to a third party. And obviously you have no control, but you also have no effort. It costs you nothing, because somebody else does everything for you. And I think it's important to have these different ways of doing things at different layers in the stack, because institutions should be able to choose how they want to participate and integrate themselves into the national infrastructure, the open infrastructure of the nation. And they should do so based on a calculus of how much control do I want and how much money do I have that I'm willing to spend. And a trade-off between control and money is obvious. And we should also acknowledge that some institution may never be able to join open national cyber infrastructure because of a mismatch between the effort they have and the control they desire. If you desire control, you have to have the money to afford the control, because control requires effort, and effort costs money. Now, so how do OSG and PRP relate to each other? In a way, there's a complementarity in implementation. Given that we have the same goal, we are complementary in how we implement. And this is sort of oversimplified on both counts, but let me just leave it at that as a guidance way to think about it. OSG is focused on campus cluster integration. That's we do with the CEs, the data origins. They integrate infrastructures that exist at campuses. Pacific Research Platform is focused on individual node integration instead of clusters, meaning you add a single compute node or a single data node, and I'll tell you more about what that means, to the integrated national platform. And PRP is therefore a single Kubernetes cluster across the globe. Literally, there is, and I didn't bother putting a map in, but you have nodes in the Kubernetes Nautilus cluster that are in Guam and that are in Europe and Asia, in all over the US. So there is it's very broadly distributed, but it's a single cluster. And so let me start to understand where things come from. It's always good to look at the history. The Pacific Reach Platform was funded by an NSF CC Star DNI DIPS award and PI Larry Smar. And then in addition to it, it got its hardware from another award, also by PI Larry Smar, that was funded via a CINU program in CNS. And the gestation is important because it means that traditionally PRP has a strong networking focus and a strong computer science focus as customer community. Since then, multiple other awards and community investments have provided additional hardware and so forth. And but there's a substantial machine learning community, which means that there's the JCI basically funded only GPUs to first order. And so, and you'll hear more about this in a moment. So in a funny way, both the kind of resources that are available, the way that they are available, and the community that is by counts of number of users dominating is all complementary to OSG. And that's sort of an interesting historical accident on some level. And then the other thing that it should be acknowledged is that initially this was just a West Coast, basically up and down the West Coast. It went all the way to Washington, if I remember correctly, and included sort of 20 institutions on the West Coast and nobody else. And due to its success on the West Coast, it then became global over time, sort of creeping along. And so now what is it actually? It shares bring your own resource philosophy, is identical to OSG. PRP wants people to bring their own hardware. In PRP, they typically talk about from soup kitchen to potluck supercomputing. Soup kitchen, if you don't bring anything, you still get fed. And potluck is you bring your own dish, meaning your own hardware, and therefore you get to share with others. That's sort of and that is identical to OSG. So there's really, in terms of concept, there's no difference, or goal, there's no different. However, when you look at the implementation, it's very, very different. PRP pioneered integration at the Kubernetes layer and the IPMI layer, integrating resources at the single node level. And that also meant that from day one, PRP focused on providing hardware suggestions. So literally, you can go, if you click on this link, if I were to click on this link, it would get me to the annual shopping list for a year since 2015. Every year there's a different shopping list, and they get sometimes a new hardware gets added onto the shopping list. And the 2021 shopping list has 11 different options right now, including 8-way GPUs, 4-way FPGAs, and just storage. 648 terabyte single node systems of SAS, and they are then joined at the KNS layer, or you can join at the IPMI layer, meaning the institution may choose to be responsible for their own base OS install, or may choose to not be responsible for anything, just be responsible for power and cooling and networking. And voila, everything else is done from, and the people who run it is, it's a little bit in transition right now. It used to be only people at UCSD. Now it's transitioned to people at UNL, and Derek and Gahan would have to tell me where exactly the line is at this point. There's global hardware integration across 30 plus institutions. What's interesting is, given that it is really cheap to participate, because a lot of these systems even are gaming GPUs. So in the beginning, only gaming GPUs were offered via PRP, because that's where the bang for the buck was for the machine learners. And so as a result, there is an unusually large number of MSIs. Out of basically a third of the total number of institutions are MSIs, minority serving institutions, 8 of which are in California, which speaks to the history of PRP being originally a Californian thing. And the user interfaces are also kind of orthogonal almost. Predominantly people interact with Jupyter or kubectl. There is, in terms of user count, Jupyter or kubectl is the dominant interaction. OSG, as I'll talk about in a second, is a way. And very recently, we've added Condor as an access mechanism, but so far it hasn't been adopted much. So it's basically one group from Stanford that is doing this. The community is dominated by CS and computer science and electrical engineering, and you have 500 plus GPUs and many petabytes. I think it's 4 petabytes of disk space and 510 or so GPUs at this point. And the how PRP interacts with OSG. OSG operates, as you will hear from Lincoln later today, 2 Kubernetes clusters in fixed locations, Wisconsin and Madison. And anything that can be located there in terms of services will be located there in OSG. However, there are things that are fundamentally distributed, meaning a data origin has to be located with the Kubernetes at the data origin. Data caches have to be located where in the places where the caches are needed. So these kinds of things are not locatable into Madison and Chicago for the entire globe, because that wouldn't make any sense. And therefore, we use today we use PRP to deploy to integrate the hardware onto which path then operates the services. So the path team that operates caches, for example, operates caches in part on top of PRP in a namespace that of OSG and PRP. Similarly, PRP appears as a single cluster. Given that it's just one cluster, it appears as a single cluster as a compute resource. If you go to Grack, look for SDSC PRP, that's actually the PRP cluster, which is then itself distributed across those 30 institutions I mentioned earlier. And so in a way, PRP hides infrastructure at 30 institutions behind a single CE infrastructure and enters OSG as a single CE. And here's the last year from Grack. I literally just screen grabbed the Grack information from the last year. It's more than 1 million GPU hours. I only take the GPUs because the CPUs are negligible in comparison to what's going on OSG. Whereas in terms of GPU providing, it's actually a substantial fraction of the total. And it peaked at above 10,000 GPU hours per day. And of course, IceCube is the dominant user, but there's a whole bunch of others, as you can see here. So now where are we going? What's new in 2022? The new thing in one line is we're systematically covering the entire continental United States. The picture is this here. So what the award we have won, which is this NSF number here, includes hardware, compute hardware in 3 places, storage hardware in 3 places, and then includes caches in 8 places. And so we're going to place 8 caches in locations strategically chosen, such that to good approximation, every single place in the continental USA is within 500 miles of a cache. And the way this was arrived was literally me taking Google and taking the US map, taking the Internet 2 backbone, asking myself, where can I locate 500-mile circles in order to cover the United States with as few circles as perfectly as possible? And this is what I came up with. And so this is I want to put a small nod to the fact one of these computing infrastructures is actually going to be doing more than just HPC. One of these computing infrastructure is more esoteric, including FPGAs and HPC to some degree. But most of all of this is just high throughput computing. And most of all of this will be accessible via, in fact, all of this will be accessible via OSG, including the funky hardware in SDC. Now, what's the data infrastructure model of NRP? And given that I told you that there is a strong focus on potluck and soup kitchen, the notion is to support regional staff storage systems across the USA. Imagine that you have fundamentally the following trade-off. For ease of use, you ideally want to have global file systems, right? But we all know that global file systems don't work because of latency. So what do? You make a compromise. And I'm all for compromises. So the compromise we're making is regional storage at institutions that are close to each other in metropolitan centers. And then those regional storage systems can become origins of the data federation. We're therefore adding capacity to the data federation. In addition, you can, we provide a replication, a user-controlled replication system. Think of it as a service. A user gets an allocation of sorts, meaning a quota on the storage, and they can choose to use the quota across multiple regional storage and can say FKW/foo should be replicated in the West Coast and the East Coast. FKW bar should be only existing in the middle of the country or such thing. And that kind of interface will be available. Then there's the caches that provide ubiquitous access. And then in terms of totality, I'm guessing that by the end of 2022, across all of the projects, including the path hardware that we're expecting, we will have about slightly more than 10 petabytes of data origin storage in OSDF to support open science by the end of 22. That means there's going to be 4.5 petabytes from NRP. There's about 4 petabytes today in PRP. And then, I've forgotten how much Brian ordered for the OSG Connect access points, but it's going to add up in the neighborhood of 10 petabytes or so. The other thing that should be obvious based on the description is that NRP is a much more experimental data infrastructure than the OSDF. And it's these individual Ceph storage systems, the regional Ceph storage systems, which are regional file systems, is the place where we'll be doing the bleeding. And the replication, user level replication service is the place where we'll do the bleeding. And we'll see how well this works. And it may eventually become a more broadly adopted service, and we'll see how we do. The caches are really more generic. It's basically the same that we're already doing, just more and better distributed with actually a map in mind rather than random. Summary and conclusion, I want to focus on the beginning. What's the vision? I think I'm following here it takes a sub-infrastructure ecosystem of collaborating projects to build and operate the open infrastructure that will achieve our joint vision. I think this is really, really important, and we can't stress this more. If we don't pull, if we're not open and as open to pull as many projects together as we possibly can in order to benefit and follow this vision of democratization of science, we're never going to achieve it. It's not going to be, the NSF will, or no funding agency will ever just choke up enough money to one project to make this all work. That's just not how things work. So I'm therefore encouraging all of you to join us. And when you think about solicitations in the future, think about how they relate to the big picture vision of democratization of science and ask yourself, how can I, given what exists, how can I work with the existing investments of the NSF and add to those investments in places where they fall short? And there's plenty of places where the existing investments fall short. And then we figure out how to collaborate with each other, and we figure out how to achieve our collective vision. And that's all I had to say. Thank you.